All right, let's do it. Start with some probabilities. Probability is favorable over total. Of all the ways something can happen, how many of them are what you want to happen? Out of all the ways something can happen in general, how many of them are what we need? That's what probability is. The situation reads like this. A child's piggy bank contains 6 quarters, 4 dimes, 5 nickels, and 7 pennies. How many coins are in their piggy bank?
22.
Again? 22 coins.
22 coins.
They reach in and pull out 3 random coins. How many ways can this be done? When I reach into the piggy bank and I pull out 3 coins, does the order I take out the coins matter? No, so this is a combination. We can answer these just like we did with the lineups. How many coins are there to choose from when I reach in? Brooke just said it. It was 22. I'm selecting how many? 3. How many ways can I choose any 3 of 22 coins in the piggy bank? How many ways can I do this in total? $1,540. Now that's going to be a helpful number because when I start doing probabilities for each of these next few questions, I'm always going to divide by what total number of combinations. How many ways can I take out 3 coins in total? 140. Now let's think about what I want to have happen. When I reach in, what's the chance I pull out all 3 coins that are quarters? All 3 of my coins are quarters. Why is 6 choose 3 important?
6 quarters.
Okay, so I got to figure out how many ways what I want to happen can actually happen. I know how many ways in total. What about the favorable outcomes? How many ways can I reach in and pull out all 3 quarters? There are how many quarters to choose from? 6. 6 choose 3. 20. So write this as a probability. How many ways can I take out 3 coins in general? How many ways can this be done? 1,540. So our probability is out of the 1,540 ways I can pull out 3 coins, how many of them involve 3 quarters? You want to reduce that down or write it as a percent? It's about 0.013. About 1.3%. Reach in and take out 3 random coins. About 1.3% of the time, you're going to pull out 3 quarters. Because there's lots of different ways it could be done, right? There's 22 coins. Only 6 of them are quarters. I'm going to reach in and pull out 3. That's what it is. How about 2 dimes and a nickel? I'm going to reach in and I'm going to pull out 2 dimes and a nickel. Eric, how many dimes are there to choose from? 4. So let's first figure out how many ways this can be done. 6 choose 2. I need the nickel. Isabel, how many nickels are there?
Where'd you get 6 from? Yeah.
Oh, dimes. I'm sorry. I'm thinking quarters still. 4 choose 2. Pardon me. I'm sorry, Isabel. Let's do a nickel. How many nickels are there to choose from? 5. Of the 5 nickels, choose any one of them. I've got 2 different kinds of coins, so I need 2 different combinations to do this. What do I do with these 2 different combinations? Wow. I'm trying to figure out how many favorable outcomes are there. How many ways are there to pull out 2 dimes and a nickel? So that way I can just divide it by 1,540 and be done with my answer. Be all done. So we've got 4 choose 2. And 5 choose 1. Only 30 now. Okay, so let's write this as a probability. There are 30 ways to do it. Out of how many in total, Michael? How many ways can this be done in total? Okay. Make a wild guess. Every single time we're going to divide by what number? 1,504. I'm always dividing by the total number of ways I can pull out 3 coins. Reduce that down if you like to. I'm just going to get a percent. 30 out of 1,540 is about 1.9%.
How's that more?
There's different coins to choose from. 2 dimes and a nickel. Now there's 9 coins you can select out of the 6 quarters versus for the first one. Okay, at least 1 penny. That at least one situation here. Why is at least one a little bit more complicated? How many pennies can I pull out?
7.
Okay, there's 7 pennies to choose from. How many pennies can I pull out and have in my hand?
3.
3 or
2.
2 or
1.
1. So I have to have at least 1 penny. I gotta have 1, 2, or 3 pennies. Any combination of either 1, 2, or 3 pennies is at least 1 penny. Yeah, we could all sit here and I could do all the combinations of 1 penny, all the combinations of 2 pennies, all the combinations of 3 pennies. What's a better way to do this? A faster way to do it? What can't I have happen? Yes,
Non-pennies.
non-pennies. Let's subtract the ways I can't take out a penny, the total number of ways possible, because what's left over will have at least 1 penny in it. All the different combinations that have at least 1 penny. Let's take the total number of ways minus no pennies. What can't happen, subtracted from the total, should leave me all the different ways I can take out at least 1 penny. So in total, there's 22 coins. I need any 3 of them. I don't want pennies. How many coins aren't pennies, Jalen? How many coins aren't pennies? 15. How'd you get 15? Right. There's 22 coins in total. 7 are pennies, so the other 15 shouldn't be. Once I subtract all the combinations that don't have pennies in them from the total, what's left over should be all the different ways I can take out at least 1 penny. 22 choose 3, minus the 15 Shaylee said choose 3. 1,085. Right, this has a probability next. It's 1,085 out of what?
Out of 1,500.
Much more likely now, right? Because there's lots of different ways that's going to happen. These are much more unlikely because it's one specific outcome. At least 1 penny is a lot of different outcomes, either having 1, 2, or 3 pennies. 1,085 out of 1,540,
You had 70%.
about 70.5%.
We'll round it
About 7 times out of 10, you'll have at least 1 penny. Reach in and pull out 3 coins.
Let's just do this.
See this last one here, no more than 1 nickel. Probability of no more than 1 nickel. How many nickels can I reach in and pull out? No more than 1.
So you would probably have to do like to choose, there'd be a total of 5 nickels. And you have
5 nickels. I take out 3, but I still want no more than 1. How many nickels could I have possibly pulled out if I want no more than 1 nickel in the 3 that I took? 1 or none. Because couldn't I reach in and pull out no nickels? That's certainly an option. Let's figure out the ways that I could get no nickels. The number of ways I can get 1 nickel. And what do I do those different ways? Add them together. Just combine them. If I want no more than 1 nickel, I can either have no nickels or 1 nickel. So let's just put those combinations together in total. No nickels, no nickels, no nickels. How many are not nickels?
7.
Well, there's 5 though.
17.
17. Of the 17 coins in the piggy bank that are not nickels, I'm going to reach in and pull out how many actually? I want none of the 3 to be nickels. So how many not nickels do I have?
0.
I want no nickels. 17 coins aren't nickels. I need any three of them.
Oh my god.
Should be at least 2.
Anybody at least two.
At least 2.
Shoot.
Was that at least 2?
Anybody, I still don't understand your question. 17, choose 3. How many ways are there to choose 3 coins from those that aren't nickels? 680.
At least 2 possibilities.
So, I want you to think about like 2 coins or something.
It's 2 possibilities.
There's 680 ways to reach in and pull out no nickels. I want 1 nickel. How many nickels are there? There's 5 nickels. 5 nickels to choose from. How many nickels do I need? 1. What are the other 2 coins? Don't. If one of them is a nickel, what are the other 2 coins? I've got 3 in total. One of them's already a nickel. What are the other 2? Would not be nickels. You bet. There's 17 coins that are not nickels. I need any 2 of them. $180 again. That's kind of random. I don't multiply them. That's what you said. I add them together. There's 680 ways to get no nickels. There's also 680 ways to get 1 nickel. So if I want no more than 1 nickel, it's just these 2 different outcomes combined together. 680 and 680 is
360. 1360.
Thank you. The probability is 1360 out of 88.3%. Questions you guys have here?
What number is an unrelated fraction somehow?
I usually go out to like 2 or 3 decimal places. You can answer as either this fraction, Alan, or the 100 decimals. Because isn't it just the same thing?
Yeah.
Who cares?
But we have to reduce it if.
Fractions should always be reduced. Obviously, that one you can just cross off the 10, cross off the zeros,
Yep.
divide by 10. How would you start reducing from there? Your calculator also reduces fractions for you. I'll show you.